The learning component of the model includes crafting classroom activities according to the best principles of promoting learning. The principles of learning are active involvement, patterns and connections, informal learning, direct experience, reflection, compelling situation, frequent feedback, and enjoyable setting. More information on this can be found in the Technology as Facilitator of Quality Education model. The teacher in this high school physics class begins with a review of mass, velocity, force, and acceleration. The students use their prior knowledge to define each variable and determine the relationships between them.
You know that if you push or pull something, what happens to it? It moves. And if it moves, it's changing its velocity, so there it's accelerating. So we know that we're going to have these two. Well, whatever we're moving has what? Mass. So by default, we've got three variables that we've got to deal with.
The students establish patterns and connections as they describe how each concept relates to the others. The students show active involvement as they participate in a lab activity. The teacher gives the students a set of lab materials, but only general instructions on what to do with them. Working in groups, the students must design an experiment that will determine the relationship between force, mass, and acceleration. As the students design and implement their experiments, they construct their own mental model of Newton's second law.
Oh, we need that. Set that up. And if we just run the cart down the ramp and then have it go through the show gate, it should tell what the acceleration is. Yeah. Have to get some right weights.
I'm needing note card.
Hey, Mr. Munson, do we have a note card?
Do
we have a note card?
Note card.
Measure in centimeters.
12 centimeters.
No,
But
we're doing
measure it that
this way.
Well,
Get back
this
together, we
is
got to make sure everybody shares that.
7.5 centimeters.
Okay.
How do you want, how is that, what unit is that in?
0.075.
Read it.
See, that would be
Okay.
genius.
Yeah. That'd be 7.5 centimeters. Because that's in
Is
meters.
it in meters? Okay, so that's good then?
Yeah. Can you close it?
Please don't let it go. You ready?
Ready? So then 0.069 and 1.07.
Okay.
Want me to do 200 again?
Yeah.
0.0695.
1.07.
Okay.
The students execute their experiments and record their data on force, mass, and acceleration. Then they examine their data and draw conclusions about the relationships between force, mass, and acceleration. As they work together to determine the algebraic and graphic expressions that describe Newton's second law, the students demonstrate reflection.
Jeff, did you do one where you kept the system the same at the end?
Yeah.
Did they change your numbers much?
When we had 150 in the car and 50 in the string, it was 0.15. When we had 150 in the string and 50 in the car, it was...
Okay. If you look at, this is your weight. Your force is going up. What's happening to your velocity, to your acceleration?
going up.
Going up. So what kind of relationship are we looking at?
Direct.
A direct. So if you look at force and acceleration, we're direct. So general shape, something like that. Now, look at your last numbers that we did. When we took the mass, and here we increased the mass of the car, and what happened to our acceleration?
Went down.
Went down, keeping the force. If, in other words, if I loaded a bunch of weight on my, if I kept this the same,
Yeah, okay.
and loaded a bunch of weight here, what happened?
Did go down.
Go down. So what's the relationship mass and acceleration wise?
Inverse.
Inverse.
That's all you want. Okay.
Fairly the same. Close.
Yep.
Okay, if we look at the variables, you need to have a relationship between mass and acceleration. If the mass goes up, what happens to the acceleration?
Acceleration increases.
Okay, I can do that.
Do we have that? Do we have that number? When we went at the end.
Yeah, our acceleration is going up pretty constant.
Accelerations with force. Force and acceleration. If I look at those two.
It's pretty relative.
Okay.
I'm just going to go through nothing.
You're getting what?
Something to me.
Something on that order? Curve, straight, what is it?
Pretty straight.
Pretty straight?
About 1 for every 10.
Okay. What's going to happen if all of a sudden I start loading weight on here and keeping the force the same? What's going to happen?
Put mass in the car. Acceleration's going to go down.
It's going to go down. So if you talk mass and acceleration, what are you talking about? What kind of shape?
Why don't you write them down?
Hyperbola?
Write them down next.
So you're saying inversely relationship.